The elements, a visual exploration of every non-atom in the universe. Today we will be continuing our exploration of this element with sulfur. Alright, I'm gonna stop this stupid accent. Sulfur. Sulfur itself is very smelly stuff. What do you think skunks smell so smelly when they just take out their smell stuff? I was talking about their gas. There's just no way about it. It's smelly as a powder and it's smelly as a solid crystal. No way are you gonna get out of it. And when it's burning, you understand why many traditions fill their hell with brimstone. Sulfur's historical name is brimstone. Many sulfur compounds themselves are similarly unpleasant, including hydrogen sulfide, which is the smell of rotten eggs. Sulfur compounds are released from burning coal, oil, and diesel fuel, which are major components of smog. Basically, every time you whiff smog, you are whiffing sulfur. Very unpleasant, in my opinion. It is one of the 3 basic ingredients of gunpowder, surprising, and thus has blood on millions of its hands, including whatever the other 2 ingredients are. Well, is there anything positive about sulfur? There is one thing though. Sulfur is very useful. Vast quantities of it are produced and consumed in the chemical industry, primarily focused in the form of sulfuric acid, which is in our guts, I should mention to you. And even though it's smelly, you can also buy it for your garden to maintain your pH levels. I don't want to talk about smelly stuff. Its atomic weight is 32.065, its density is 1.960, its atomic weight is 88 picometers, its crystal structure is just a regular cuboid, no oblong stuff. Its atomic emission spectrum, it's how should I describe this? Very balanced, but very few. It has a slightly higher electron filing order than number 15. Its state of matter is mostly a gas, not surprised. It's a liquid, apparently, and even a solid. That's not surprising, but liquid? Next, we have chlorine. If you remember from, like, a video back, you'll remember me talking about, say, a certain kind of sodium. Well, sodium plus this equals, let me write you the equation, Na plus Cl equals salt. This was used in World War I as a poisonous gas weapon. Everyone used it, including the Germans, including the Allies. And then everyone decided that this was useless. Mainly because, yes, the enemy died. But you also died. Whoever set it off, everyone died. No matter who set it off. If the Germans set it off, the Germans died as well as the Allies. If the Allies set it off, the Allies died along with the Germans. No one was safe. Who can control gas? Gas blowers? Soldiers would wait in position in their gas cylinders at the front lines and wait for the winds to shift towards the enemy. Then they would just open their valves and run like hell, which usually didn't work. Yeah. If you inhale small whiffs of pure chlorine, it won't do enough to do some injury, but probably close to the age. The sensation is, apparently, according to the author, one of pure instant agony, as if someone is pointing a blowtorch at your sinuses. Death by chlorine gas must be unimaginably awful. I can't believe someone would be so stupid to smell a little bit of chlorine. On the other hand, though, it is one of the smallest amounts, it's one of the cheapest, most effective, and least harmful of all the disinfectants in the world. You save millions upon millions of drinking water and wastewater with no longer lasting environmental effects. Why do you think a lot of swimming pools have chlorine in them? On balance, though, chlorine has saved vastly more lives than it has taken. It saves millions of lives, it saves like billions of lives, unlike how many millions of people it killed. It is one of the components of hydrochloric acid, which is inside our guts, sulfur, and it has a diverse element. It's only found as a gas, with some rare exceptions, as a solid, as I'll show you later. Its atomic weight is 35.453, its density is 0.003214, its atomic radius is 79 picometers. Its crystal structure, it's a cuboid, but slightly oblong. It has not very balanced. It's on the extreme ends of the atomic emission spectrum. As from what I can see, it has an electron filing order that's slightly higher. It's mostly as a gas. Rare occasions, it's a solid, and rare occasions, it's a solid, and even rarer occasions, it's a liquid. Then we have argon. You thought this was neon lighting? It's argon lighting! Argon is from the Greek word for inactive, which it exactly is that. Nearly all of its applications relate to the fact that it is the cheapest totally inert gas. Nitrogen is even cheaper and inert enough so that maybe, well, enough for many applications, but at high temperatures it will break down. Argon remains the same thing, even though it is at high temperatures. Edison's first light bulbs used a vacuum to protect the filament from oxidation, but modern incandescent bulbs are instead filled with a mixture of nitrogen and argon. Like modern LEDs are filled with, like, modern light bulbs are full with argon and apparently nitrogen. At near atmospheric pressure, meaning it's almost at the pressure of outer space, allowing them to have paper-thin glass walls, which means that they break easily, unfortunately. Fancy smaller bulbs are filled with krypton and xenon or halogen gases to allow their filaments to grow, burn hotter, and thus brighter. Careful though, you don't want to burn yourself. You can even turn it on and cool it a lot, and then you will turn into this flashy light. Pure argon gas is invisible gas, and small disposable argon cylinders are used for wine protection gadgets, apparently. Apparently, the offer has a wine protection gadget full of argon in it. Yeah, I think I believe that. I believe that so much. Argon itself is very inert. All you have to know is that. Its atomic weight is 39.948, which is about 40. Its density is 0.001784. Atomic radius is 71 picometers, and its crystal structure is a very straight cube. It has a very balanced, except for one exception part, this part, of an electron atomic emission spectrum. Its electron filing order, it's even higher. And it is only found as a gas, except for the rare occasion that is found as a solid. Now, a little note on the atomic weight. Remember at the very beginning of this series, the introduction video, where I mentioned that atomic weight is roughly two times the atomic number of the element? Well, that number, roughly, as it grows bigger, it'll become even more rough. So it is still quite accurate. To a certain degree, as you go up, accuracy goes down. Now we go to potassium. Potassium, very radioactive, very good. It's very healthy for you. It's for bananas. It's in bananas. Go to Cuba and you get a lot of potassium. Monkeys get a lot of potassium in their body because they keep eating bananas. Man, I love that rant. I always want to do that. Radioactive bananas, even though that's kind of false science. In fact, every food is radioactive. Bananas just slightly more so. The reassuring truth. That's the reassuring truth. Virtually everything you eat is radioactive. Don't worry, your bananas won't kill you. It's just a radioactive isotope. It's potassium-40. That's a radioactive isotope. Very small amounts of radiation, though. It won't kill you. I have said that 3 times. Radioactive bananists, please at least make sure that they know that the radiation dose is very low. Potassium in the earth itself, it mainly grows as bananas, as I already told you, of course. And it's used a lot inside no salt. It also tastes very salty. In fact, when you cannot eat sodium salt, you can just eat potassium salt. Tastes like salt, and it doesn't have any sodium. Usually good for your health. But other kinds of salt, it gives you a kind of a metallic aftertaste. Fortunately for me, though, I've experienced metal tastes so much that I will probably not mind. One little note, though, when your nerves are starting to get cold and your nerves are starting to function less, well, the first thing you gotta do is eat some bananas if immediate medical care is not enough. It's not coming immediately. Its atomic weight is 39.0983, its density is 0.856, its atomic radius is 243 picometers, and its crystal structure is kind of straight cube. It has a very middle part. Its atomic emission spectrum, it's in the middle part, and for some reason it's skipped an electron filing order completely. It's mostly found as a gas. Most of these elements are found as a gas. And it can even be found as a liquid, but on rare occasions you can find it as a solid. Finally, we have calcium. When you say calcium, most people will probably think of milk, and I'll think of milk too. Either that or bones, or even chalk. Chalk itself has a lot of calcium in it. because it's chalky. Calcium is what gives us this white chalky stuff, that chalky feeling. Both kinds of chalk that you can find. The calcium found in milk are compounds of calcium. Calcium itself has been inside the earth for so long that it's just there. Calcium sealing stuff. Calcium stalagmites exist, and you can just go ahead and chuck that off and give yourself a little calcium. You need calcium to grow your bones, merely because your bones require calcium. Your bones are created from the same stuff as the calcium stalactites or stalagmites. Both of them count. Most skulls, though, you can always extract some calcium from it. If you want something to add to your collection that's made of calcium, look no further than some human bone. Or unless your ethics are too bad or too high to killing a fellow human being, well, you should go ahead and get a lizard's skull. Or you could just go for plain old chalk. Much more ethical. Its atomic weight is 40.078, its density is 1.550, its atomic radius is 194 picometers, its crystal structure, very straight cube according to my observations. Its state of matter is very balanced, in my observation at least, and its electron filing order, it's still skipping, it just filled up another one. It's mostly gas, sometimes a liquid, and more often a solid. Also, not even a third of the gas's probability is a solid. And that's it. That's it for today. That is elements number 15 to 20. I hope you guys enjoyed this. I'll see you guys in number 21. Woohoo! We finished 16 to 20. Yay!